In 2008, I first discovered test derivative. It was awesome. I thought I'd never make a mistake again in my entire life, and that lasted about 10 minutes. But still, I started reading about it, I went to courses, I was really stoked, and by sort of mid-2010, I was like Emperor Palpatine from Star Wars, only taller. And I had like lightning bolts shooting out of my fingers of awesome code, and I was this coding god. In reality, I think my coworkers experienced me more like this guy, only taller. But be that as it may, things are going well, and in my head, I was a rock star, and seeing as most of the stories about what's going on in my head, that's okay. But then last year, I started to notice something. When I started on a project, TDD felt awesome. It was this green rolling field of hopefully non-GMO wheat. That Julie Andrews would run through singing songs about the Von Trapps, and it was fantastic. And projects always started like that. It was wonderful. And then you get your nose to the grindstone, and time passes. And you notice that when you look back, it's sort of like Mad Max's backyard. You've got tests that you're not happy with. You're thinking, which idiot wrote this? And you know which idiot wrote that. It's you, because you do the git blame, hoping it's someone else. That moment, that pause before git blame comes up, and you're going, oh, please God, please God. No, it's me. So there's no one you can blame. And at Hetzner, we take testing quite seriously. We've got what I'm told is an atypical environment. We have lots of very complicated legacy systems written in PHP with no tests. It's effectively procedural spaghetti that's very test resistant. And in some cases, the software is so complicated that for a while it seems standard operating procedure was to go, let's not fix the bug in there. Let's write another system that's infinitely less complicated than this one to come along and clean up afterwards. And then when that one becomes too complicated, well, we'll slip one in next to it. And so we're not complete idiots, or at least I'm not well, maybe I am. But what we started doing is we started extracting that functionality into a collection of smaller systems. So these systems are well tested, they're well written, they're in a technology that makes sense for what they're doing, and they're awesome. The only catch is when you have lots of small systems, you have lots of system boundaries. And every so often across the system boundary you get something wrong and bad things happen, and so that's something you're quite worried about. And so we've invested quite a bit into using Vagrant. We have multiple VM environments running in Vagrant. Some of them I think are like 7 or 8 VMs at a time. It's awesome if you're a memory salesman at Hetzner. And so we've invested quite a bit in trying to catch those problems. So that's enough about Hetzner. We're going to go on to what's important in this talk, which is me and my problems. So what I noticed is that my tests were polarizing. That was the symptom for me. There's probably lots of other problems, but that's the thing that I spotted. My functional tests were clumsy, but they were useful. So they caught bugs. But they took like an age to set up, because you've got to tweak all the knobs to just sort of guide your path through to the happy path that you want to test. They're slow to run, because there's a lot of tear down, setup stuff that's going on. When you find a bug, it's unbelievably slow, because Captain Obvious says it never breaks where you're expecting it to break. So you spend a lot of time debugging, where the hell did the setting come from? And finally, when someone else takes my test, it's very hard for them to read, because there's so much fixture. They're looking at this thing and going, what the hell's going on here? And so it's just expensive all around. And so, what do your other tests look like, Rory? I hear you say. No, seriously, what do your other tests look like, Rory? I hear you. This would have worked if this was a C# one. Thank you. Thank you very much. So my unit tests were fast but essentially useless. They never caught any bugs that I cared about. And because I was using mocks and stubs to like the nth degree, I'd bled all the implementation into the test. So what I do, if I want to refactor, the first thing I want to do is I've got to go change my freaking test. That's gross. You're supposed to have the test there as your safety net, and what you're doing is you're shifting it around to try and catch where you're going to fall. And so this left me with the elephant in the room, something I needed to do something about. And for the purists, I know I could have picked for a useless car, I could have picked a picture of a Land Rover. But I wanted something that's actually faster than a tank. So I was at the point where I had to choose. So option A is I can ignore it and hope it goes away. And this, it's not very adult, but I'm told it prepares me well for a lucrative career in politics. But the problem is with this, it takes quite a bit of concentration to keep on ignoring something, and I've got a really short attention So my other option was to stop writing tests. And despite what Walt Disney movies will have you believe, that's actually quite a pragmatic option. You can give up something if it's really not working for you. In the past, I've given up on ever meeting Father Christmas, dancing for the Bolshoi, becoming a professional jockey, becoming Indiana Jones. 2013 was a really rough year for me. But the problem with stopping writing tests is it assumes that I understand all the benefits and all the costs of what I'm giving up, and I don't. I don't feel like that now. Sorry, spoiler alert. And I didn't feel like that then. So the only option left for me was to find a new path, to find new places where I could send my tests, to boldly go where my tests haven't gone before. And did anyone else hear these are the voyages of the Starship Enterprise in their head, or just me? Okay, that's awkward. And to start off, to do this properly, the first thing I had to do was I had to give up everything I thought I knew about TDD. I had to throw it all away, all the biases, all the beliefs that I had, and I had to start getting knowledge basically as if I was a noob, which was quite convenient because I was. And so I was lucky in that at Hetzner, we collaborate with organizations like Stillpoint and Cielo with depth of knowledge about TDD. Last year, I sat through both sets of Martin Fowler's talks. I was privileged enough in January to attend Dan North's Accelerated Agile course, and that's excluding books like Growing Object-Oriented Software, which, yes, it's a Java book, but it's still awesome, and Sandy Metz's Practical Object-Oriented Design with Ruby, which are both awesome books and which I can highly recommend. And what I'm going to do is most of the stuff you'll see from here on is an amalgam of all those sources. So if you see something and go, hey, I think you stole that straight out of Growing Object-Oriented Software, the answer is yes. I'm not going to refer to them every time because it makes it a bit clunky. And so I kept an open mind as well in terms of the tools that I'd be using, with one exception. And that exception is Cucumber. I can't open my mind wide enough to fit Cucumber in there. But if you are using Cucumber in a non-trivial setting and you're not crying yourself to sleep at night, please come tell me how you do it, because I'd love to know. So the first area of changes came in the philosophy that I have towards testing. So this is very sort of warm and fuzzy. At Hetzner, and I think in most places, when you introduce something, there's various levels of adoption. So some people end up not doing it all. Some people are the golem of testing. I mention no names. And as a result, I developed a very defensive posture towards that. So I'm going to write my test to be as complete as possible to make sure that no one ever breaks this. It will cover everything. It will be this all-inclusive beast of a test. And so all that happens there is I'm introducing more craft. I'm creating a place for bugs to grow. I'm not actually doing anything about fixing them. And so that's the first thing I let go of, to greater or lesser degrees of success. And the reality is, even if I end up working with this guy, whose heart is in the right place, but whose brain clearly isn't, or even this guy, who really doesn't care about the tests at all, tests are not some sort of enforcement method. Right? They're not going to stop them. What you want is you want to talk to these guys and find a way and deal with it like adults. And if that doesn't work for you, elephant tranquilizers. You can shoot them from a rifle. You don't have to be close to the guy. It's awesome. They last for a really long time. The second sort of change in philosophy is the dual nature of quality. The external quality is what stakeholders are paying me for. That is that this thing still does what they want it to do to make their problem go away. And functional tests protect external quality. They make sure that I'm still delivering what I promised I would do a week ago, a month ago, a year ago. And the flip side of external quality is internal quality. And internal quality is the ability of it's a measure of the ability of your software to change and to flex as the circumstances around it change. And so unit tests guide internal quality. They're not there to catch bugs. They're there to tell you that you're doing a crap job of writing code because it's hard to test. And that already for me was like quite a moment that sort of relieved some of the tension that I was feeling. My software is crap though, but so that's a separate talk. And along with that came some new mental tools. And there's probably lots more to come. So I'm touching on a very small subset because the journey for me so far hasn't been very long. The first thing is, what am I missing? In every project, there's stuff that you don't know. It's called second-order ignorance. And effectively, if you're a Donald Rumsfeld fan, it's his unknown speech. And the thing I've got to admit is that no matter what I think I know about something, no matter how much of an expert, there's something I'm missing. And no amount of talking about it or drawing pictures on a whiteboard is going to flush that stuff out. The only thing that flushes it out is working software. So the first thing I want to answer is, am I actually solving the problem? And store point refers to this as the checking for a pulse. It's a variation, I think, of Dan North's spike and stabilizer. It's pretty much prototyping. But it's prototyping and getting code out into production if you can. Check that it's actually solving the problem that you think customers have. Sometimes it's the wrong problem. And they go, oh, now if you've got this, realize X. And that's the kind of stuff you want to have as soon as possible, and it doesn't happen just once. I want to be doing this every time I get to some place where I'm certain I want to be rolling this out and checking that the lights go green. Coupled with that is something called a walking skeleton. And that's effectively a thin vertical slice through your production stack. You want to try and get something which is 0 features but connects all the moving bits out into production and see that it's working. And a second prize version of that's what you do at Hetzner. We've got the multi-VM vagrants, which are provisioned by Puppet, so it's quite easy to get them going. And it's unbelievably useful, and it's something I've generally always treated as quite a chore, and I've tried to leave it for as late as possible. Generally, when you need sort of like multi-system functional testing, okay, I'll set up a vagrant VM. But the reality is it's incredibly useful because you can remove a lot of what-ifs. I'm writing a rack app at the moment, and it's handy to go, well, if I tickle rack in this way, what does the rack ENV look like? Normally what you'd have to do if you're in like a unit testing land, you'd go, I'm not sure what this does, so I'll leave myself a to-do, because I'll definitely come back to those. And I will maybe come back and remember what this should do, and I'll tweak the test if there's time. Now you can just go, I'll just fire this at it and see what comes back, and it's incredibly useful for that. And the final part of this is deliver frequently so you can close the feedback loop. So what you want to do is small bits of code deployed into production as often as possible. If you can get it working daily, that is awesome. Because if tests are validating your software, getting your software in front of actual users is validating the tests. You're closing the loop, checking that everything's still working. So past that, we can get something which is perhaps a little bit heretical. I don't always need a test for production code. There are some cases where I'm going to ask myself, what is the return of investment on this test? Is it going to cost me more to write this test than it will to fix the bug when it appears? And sometimes, and this is something that I'm quite new to, so I might be here in 2015 going, don't do this. But it's something you need to think about. And the thing is, this is not me accidentally leaving our test, because if I do that, I'm sorry. This is a deliberate decision. I've often spent as much time thinking about the test that I'm going to leave out as I would have spent writing it. I'm thinking about what's the impact in terms of other people are going to come look at this code, what's the impact if it breaks. Dan North and Stillpoint as well will tell you about the risk, assessing the risk, likelihood versus impact. How likely is it that it's going to break? What happens when it does? And together with that is that not testing is not a binary decision. It's not you have tests or you don't have tests. A colleague of mine, Ernst van Graan, who's sitting right at the back there, you can chat to him after this. You can chat to him during this, but it's a little bit rude. Is of the opinion that it's a continuum. On one end of the continuum, you have nothing at all. No tests, no documentation. On the other end, you have a fully tested, fully spec'd, all singing, all dancing definition of your system. And in between there, you have variations. So for instance, if I'm writing something that I think is fairly trivial, and it's catching timeout errors and doing retries, and you want to check the number of retries and nonsense like that, that's maybe 4 or 5 specs there. What I might do is go, well, the only thing I care about is that it eventually stops retrying and blows up. So I'll write a test for that. The other 4, what I might do is leave them as pending specs. So what the next person has is perhaps feeling a little bit less hippie about their testing, is they've got a documentation of, hey, if Rory had actually been bothered to write tests, this is the test he would have written. Cool, I have a place to start. Gives them a bit of a leg up. If you do get to the point where you're writing tests, the important thing is to ease the burden. Tests can become bloated really quickly, and it becomes a pain to work, and it runs. We have for our one test suite, we run it in parallel across 4 processes. It still takes 15 minutes to finish. Before we did them in parallel, it took a lot longer. I think it was like an hour or worse, and that's painful. It's quite a drag, and that's where it starts. People stop caring about the tests. So one thing we had in the beginning was something called builders, and builders are a domain-specific language for building fixtures. So it's quite a high level. You want to abstract as much as possible. We used it initially, and unfortunately, I didn't give it as much love as it needed, and so it became bloated. I was the second-class citizen in my test suite, and up until I started on this journey, I'd pretty much given up on builders. It was a nice idea, but it doesn't work. But the reality is that if you apply the same amount of effort to builders as you would to your production code, because they're just as important as your production code, what you get is fixture definitions that are easy to distinguish. So you can look at it, and it turns out if you've done it correctly, which I really have, it's one-liners. So one-liner that says, this customer has an overdue account, he's missed 3 payments, compared to this customer is paid on time. You have that, which is like a one-liner, you can look at it immediately, okay, I know why we have this test, as opposed to, well, there's these 50 lines of factory goal, and there's these 50 lines of factory goal, and maybe if I stick them in 2 files and diff them, I'll be able to tell you what the difference is between the tests. And then, this one's got 10 and that one's got 20. I feel so much better now that I knew that. And so builders are about fleshing it out, making it very easy to read, because what you want to do, and this is especially true for functional tests that cross boundaries, sometimes it is really hard to figure out why this test has a right to live. Another angle, and this is something that for many months, I have a colleague called Sheldon Hearn. I used to argue with him about this. He was a big fan of adding instrumentation. I was a TDD purist, and I thought that's where the devil comes in. Often when you have when you're starting off with a class or a method, the public interface isn't well defined. And you want to make small changes and see those things happen. So maybe you're setting instance variables, you're doing things like that, but it's very difficult to get traction because there's no way to reflect the change. You end up putting a lot of code in before your test notices a change, and that can be quite slow in the beginning. And idea of Sheldon's was to just expose public methods that expose the innards of your class. And it's not necessarily public methods that you intend to keep, although you might find them useful, but it makes it incredibly easy. You can do a one-liner, and the first thing it does is sets that instance variable, and you have a getter that says, yes, you set that instance variable, awesome, and it's much easier to pick up speed than trying to find the end result, and that's 4 or 5 lines away. It makes it very easy to pick up speed and very easy to keep speed, and often what you find, which was really galling for me then, but nice and happy now, is that at the end, the stuff that you've exposed actually becomes quite useful. And if it doesn't, throw it away. And you can throw tests away as well. Sometimes a common practice is to write a series of tests so you can flush out the bug. You want to confirm that the bug exists, that it's doing what you're seeing in production, and then once it's there, you want to make those tests go green to confirm that you fixed it. The problem is often when you fix the tests, when you fix the code, the tests don't make sense anymore. Someone will come and look at it and go, who would ever do that? Why is the test here? It doesn't make any sense. And so once you've flushed out the bug, throw away the tests. Nothing holy about them. You have tests for edge cases that no longer happen or something like this. If you come across those, don't be afraid to throw them away. You'll feel a lot better. I'll feel a lot better. We'll all be happier people. So this started off with me being quite emo about TDD. This is me, only taller. And at the end of it, I feel a lot better about TDD. I don't have a lot of answers. I've got a whole lot more questions. But I at least feel like there are options. It's not this dark hole that I'm going to disappear into and forever be sorry that I did. And that for me is the value, is that there's more to know. There's more to find out. I didn't know everything that I thought I knew. But it's not the real value in the test. Clever. Not the real value in the talk. So the real value for me was the fact that I'd established a real blind spot about testing. At some point, between not knowing anything and becoming the all-seeing, all-knowing ruler of TDD, I'd assumed that I knew all there was need to know. That's okay, I'm an expert at this. I can move on and never have to think about it again. And I got into this deep, dark place where I was thinking, well, initially TDD sucks. What's wrong with this? People are just doing this to get groupies. And it took a while to actually draw back and go, well, maybe the problem is me. And to look at that, and this is, for me, it's a little bit meta. It's something that I can apply in other areas, is to go, wow, if I'm having a really, really bad experience with this, perhaps I should just throw away what I know and start over. Perhaps coming around the second time, I'll have more insight, or someone will have come up with a better way to explain it, and I'll understand it better. So for me, if that's something that's valuable to you, I hope it's worth 20 minutes of your time. I thank you for your time and attention. My name is Rory Mckinley. I work with awesome people at Hetzner. And now is the time that you can ask any questions if you want. Thanks, John. So John's question is, do I ever put the instrumentation in? So I'm assuming like mixed in at the test? Oh, okay. Okay, so redefining the class in the test and then perhaps moving it out. I haven't done that before, but that's a really good idea, and I think it's something I'd like to give a try. So thank you for that. Yes, back. I find that for me, functional tests, I'll generally have an idea early on what the happy path looks like. So that's when everything works, which it never does, and everything is awesome, and the sun shines. So I'll try, if I can, to put a functional test in for that in the beginning, if it makes sense. This for me is and so you might find that it doesn't work for you because of environment or other stuff. I've tried to make this a very subjective thing because I think testing is subjective. But I think having functional tests early, especially if you made the mistake that I have of bleeding out implementation, that's the only place you have to go when you start refactoring. If you change, I have a habit of trying to do like a lot of procedural code just until I'm sure that I'm solving the problem. And then if you've bled out a lot of implementation, refactoring that, the first place you have to go is start changing the tests. And then having functional tests there is a godsend because those are the only things you can rely on to realize that you screwed up something badly. So I'd start off with at least one or two as early as I can, as makes sense. Ben.
You said that you use a lot of Vagrant and that you try to test it. Why do you use to test Vagrant? Do you use just the normal aspects and mini tests and those things, or do you have a special framework for that?
So for a while we used Cucumber. So it's usually just RSpec. We'll run that. RSpec's the thing we're most comfortable with. So it's possibly not a declaration of its value over something like Minitest. It's just the thing that we're comfortable with. So if you do like a lot of use the RSpec sort of outside-in testing stuff, that generally works quite well. We don't do acceptance tests. Oh, okay. No, well, so we use Puppet at the moment. Puppet's the one area we're not doing a lot of testing. It's quite an old set of Puppet recipes, and as a result, testing wasn't big in the Puppet community when we started, and it's very hard to reverse it in now. It's basically legacy software. Sorry, I'll get you now. There's a question in the back.
So you mentioned your experiences with Factory Girl constructing a little bit of pain, where you described a scenario of having two factories that were intended to build the same class of object with various options. And so you say you have like a 50-line factory. Is that actually your use cases that you have with Factory Girl?
We have had some cases, and so I don't think that's the intended way to use Factory Girl, but that's the way we ended up using it in the beginning, was there'd be a lot of Factory Girl calls. And so it's not necessarily a single call, but you'd have a lot of them with a lot of parameters being passed in. And so it would be very difficult. You'd pretty much have to go line for line and figure out what's different about this. And then when it is a magic number, try and figure out what the new magic number means. So very much in my case, it was just poor use rather than necessarily reflection on Factory Girl. Whereas I'm sure Cucumber is the devil, for instance. I'm not sure about Factory Girl. Sorry, yeah.
This approach seems to me, because we are more confident with what we're doing in Ruby, and we've migrated from this scaffolding or Rails, we can step away from certain bits of code and be okay that we don't actually have to test everything. So it's sort of there's an element of maturity that comes in. What I want to know is, are we ahead of the curve in terms of other languages, or is this things that Java devs learned a long time ago and we as Ruby devs are just waking up to not testing everything now?
So I suggest you speak to Aslam. He's probably a better person to answer that than I am. But so to give you an example, Growing Object-Oriented Software was a book that made quite a sort of impact in the Java community. And that was several years ago. Sandy Metz's book, I think, is almost that's implemented in Ruby with some extra stuff. And that came out a couple of years after Growing Object-Oriented Software. So I'm not sure. To be quite honest, don't see a lot of other languages on the same level that I see Ruby. And that's not that they're immature. It's just in terms of the amount of exposure I have. So it'd be difficult for me. But definitely, Aslam's the guy to speak to if you want a good call on that. Cool. Thank you very much.
No come electo por la vida.